Hi, hello. It's still me wearing the same t-shirt because I'm recording this back to back. So for this one, we're going to discuss factoring by grouping. With that out of the way, let's just jump right back to our lessons. Now that we're done with factoring by GCF, we can now proceed to another way of factoring polynomials. This time around, we are going with factoring by grouping. There is a specific reason why these two topics are next to each other because we are simply applying the same concept without you even realizing it. So let's just jump right to it. Okay? No more concerns about overcomplicating it. Let's go with the step-by-step guide similar to the way that we discussed the few examples from factoring by GCF. Now, in this case, we determine the number of terms. You can see that we have here xy, first term, 3x as our second term, 2y as our third term, and 6 as our fourth term. The beauty of factoring by grouping is that we can have a couple of different solutions here depending on the given. So what I'm going to show first is the first way of solving this. If you see in the notes in terms of the step-by-step guide is we group terms that have a common factor. So the first thing that we can do here is the easiest one wherein we don't have to change the positions of the terms. So let's say that we have xy plus 3x plus 2y plus 6. So I'll use a different color so that you can notice it. So xy and 3x can be grouped because they have a similar or a common factor. Same case with 2y and 6. So if we focus with xy and 3x, we can already see that they both have the variable x. So that we can bring out. And that is actually their GCF. So xy divided by x, that is equal to y. 3x divided by x, that is equal to positive 3. As easy as that. Next, we go with 2y plus 6. We can already see that they don't have the same variable, but they both have a certain similarity. You have 2 as the numerical coefficient, and you have 6 as the constant. 2 and 6 have a GCF. And the GCF of those two is actually 2. So we divide both sides by 2. Or should I say, we divide both terms by 2. 2y divided by 2 is y. 6 divided by 2 is positive 3. Now, we are moving to the fun part. This is actually, factoring by grouping is basically grouping and then doing more GCF in terms of factoring. You can notice here already that they have something in common. And it's something that you don't have to overcomplicate. Class, you can see it right here. It's in parentheses already. Both of them have y plus 3. And to put this into perspective, all you have to do is to copy one of them to factor it out. Factor out the y plus 3 for this given. So you will have y plus 3 times the quantity x plus 2. The funny thing here is that you might be thinking, sir, what's happening? This is complicated. No. Again, we factor out what they have in common, which is the y plus 3. It's this one. And then, how do we get the second factor or the second group? Well, basically, it's the GCFs. So you have x, then you have positive 2. And this is your final answer. To make this clearer, let's show solution number 2. Solution number 2 is a bit different because we wish to have a different combination in terms of the groups. So what I will do first is write the given xy plus 3x plus 2y plus 6. As you can see here, class, we have xy and we have 2y. They both have a common factor, which is y. So we can group it. So we can say that we have xy plus 2y. Be careful with grouping. Please do not forget to have their symbols, whether they're positive or negative. Next, We can also have positive 3x and positive 6. So we can have plus 3x plus 6. Now, we can now factor out y for the first one. Divide both by y. So xy divided by y is x. 2y divided by y is 2. Next, the GCF here is 3. Divide both terms by 3. 3 divided by 3x divided by 3, that is x. 6 divided by 3, that is 2. Same case with the one earlier. They both have something in common. In this case, it's the quantity x plus 2. So copy that. And for your other group of factors here, it should be the GCF, so it's y plus 3. As you can see, we arrive with the same answer. Yes, the positions are quite different, but with our properties, this implies that they still have the same answer. So please make sure that you also remember the properties of equality, the properties, and with these operations, like just to make this simpler, for example, you have 2 times 1, that's 2. 1 times 2, that's also 2. Like the positions might be different, but in terms of multiplying, you still arrive with the same answer. So that's for our first example. I've shown you 2 different ways of solving it, but for the other examples, let's just go with one. Don't worry if you wish to do it in the other way, you will still arrive with the same answer. So don't have anything to worry about. Next, here we have x squared, xy, negative 3x, and negative 3y. We have 4 terms. So x squared plus xy minus 3x minus 3y. So let's write that down. We group these in different ways also. But to make it easier, let's group x squared and xy, and we can have negative 3x and negative 3y. We can group that also. But here there are dilemmas in, sir, what if it's like this? If we read it like this, it will become multiplication. So to avoid confusion, one of the ways that you can do is to rearrange it without grouping it yet. Or at the same time, you may also add a plus symbol to make it easier to understand. So we can say that we have x squared plus xy plus negative 3x minus 3y. The reason why we have to add the plus here is because if we do what I showed earlier, it will become multiplication. It will be a different expression already. So we have to make sure that we don't do that. You can add an addition symbol here. So in this case, identify the GCF. For the first group, we have x. Divide both by x. This will be x plus y. Now here, we can have negative 3. So when we bring it out, the x here is no longer needed. The positive sign pala, I mean the plus. We don't need it anymore there. So divide both sides by negative 3. Divide both terms by negative 3. You'll have positive x and you'll have positive y. Remember, when you're dividing terms of the same sign, the answer will always be positive. So here, same case, same, factor it out, x plus y, then you'll have your GCF, x minus 3. So this is your final answer for this given. Well, for the third example, we have 3by plus 4ax plus 12ay plus bx. The dilemma here is that you have to move your terms here, rearrange them in order for you to really show the grouping properly. So what I will do here is I will rearrange it such a way that you can have those terms that have a common factor next to each other without changing the expression. So you can have 3by plus bx, then we have plus 4ax plus 12ay. As you can see, the positions might have changed, but we carried the terms the way they're supposed to be. We didn't change anything. So let's group them all together. Let's group them with one another. So 3by plus bx plus 4ax plus 12ay. For our first group, they both have b as their common factor. So let's factor out the b. Factor out the b. So this will be 3y plus x. Here for the first GCF that we can look at are the numbers, which is 4 and 12. So the GCF for that is positive 4. While for the variables, they both have a. So divide both terms by 4a. This will be x. And this will now become 3y. Now you might be wondering, sir, I don't see anything that they have in common. Now one of the things that is important to understand here is that when you have situations like this, similar to the one that I mentioned earlier, you have to pay attention with the properties that are indicated in mathematics. In this case, you have here 3y plus x. You can actually rewrite that as x plus 3y because it's still the same thing. It's like think of it like this: like 1 plus 2 is 3, 2 plus 1 is also 3. That's the easiest way of me trying to explain that. There's a certain name it's called. Forgive me, I forgot it already. I'm a mathematics teacher. Please don't hate me for that. But I forgot what property this one is. Basically, the concept is 2 plus 3, that is 5. 3 plus 2, that is also 5. So there's no problem with that in terms of addition. They can also do that in subtraction, but for subtraction, you have to be careful with the sign, whether it's positive or negative. Now that we can see that they both have x plus 3y in common, let's factor that out. X plus 3y, then you have times the quantity b plus 4a. And that's it. That's how you get your answer here. It's just the GCF. That's it. And for our last example, we have 6xy minus 4x minus 2z plus 3yz. In this case, you don't have to move anything since terms with a common factor are already next to each other. So let's have 6xy minus 4x minus 2z plus 3yz. First group, 6xy minus 4x plus negative 2z plus 3yz. So for the first group, the common factor is not only the numerical but also the variable. It's actually 2 and x. So divide both terms by 2x. So 6 divided by 2, that's 3. X divided by x is 1. Bring down the y. Negative 4 divided by 2, that's negative 2. X divided by x, that is 1. So that's good. Next, the common factor for the second group is actually z. So bring that out. This will be negative 2z divided by z, 3yz divided by z. So this will be negative 2 plus 3y. Again, same case with earlier. This can be rearranged properly, but be careful. So what I will do here so that you will not be confused, I'll focus on the second grouping instead. So this can be 2x times 3y minus 2 plus z times the quantity 3y minus 2. Since they both have 3y minus 2 already, factor that out. And then have another grouping symbol multiplied to it. And the ones inside it are our GCFs. 2x plus z. This is letter Z, class. Forgive my handwriting. I think I read it as 2 earlier. Please forgive me. It's Z. And this is our final answer. And that's it, basically. And that ends our discussion. Do not forget to ask questions or for clarifications, you can leave them in the chat. Do not worry, all these lessons are here and I will try my best to post regularly in order for you all to have a guided learning outside of our classes. Same case for those who will stumble upon this. Hopefully, you all get to learn something new and get to have some tricks that will help you out and easing your way with your grade 8 mathematics life. And in that case, in case you guys don't hear me or see me, well, good morning, good afternoon, good evening, and good night. Bye bye. Peace out.